Today we're going to talk about DHCP, which stands for Dynamic Host Control Protocol. But first, before we do that, we want to go over and review video 2. And the things we talked about in video 2 were mainly gateway and DNS. If you remember, the gateway actually connects you to a different subnet or the internet. I have an example here. We have a subnet of 255.255.255, 192.168.100.5, and of course the 209.101, 100.5 with the same subnet. These two networks would not be able to directly communicate with each other, so you would need a gateway or a router to take you from this network to this network. You could not go directly to it. So that's the first thing we talked about, and then we talked about DNS. And DNS just converts a domain name into an IP address, like yahoo.com to 209.191.122.70. So if you remember, if I go Windows R and open up my run command, and then go ahead and type in CMD to open up my command prompt, I can ping yahoo.com, and if I enter, that went out to the DNS server and asked it, well, what IP address is yahoo.com? And then the DNS server gave this IP address back. And so that's what the DNS server does. Now, the next thing I want to talk about, we didn't really talk about this in video 2, but I wanted to kind of give you an idea of the basic subnets that we work with. And there's a Class A, Class B, and Class C. And the vast majority of subnets that we work with are going to be the Class C, which is the 3 255s and the 0, and you're going to have just 255 devices. That's mostly what we work with. So this, if you remember, these 3 255s mask out the network. So up here in our example, our network address is going to be 192.168.100, and so it's every IP address, if it's going to communicate on this network directly, is going to have a 192. It's going to start with a 192.168.100 something, or it won't be able to communicate. Now the next Class B right here, you notice now we just have two 255s, and that has 65,000 devices basically on that network. And the way I got this number is I just can have 255 devices here. I can have 255 devices here at different places. So I just multiplied those together. And that's how many different combinations I could possibly have using 255 numbers here and 255 numbers here. So of course the Class A is just one 255, and then these three are wide open. So on a Class A, 192 would only have to be the number that would have to match on all devices, and then these could be anything from between the 0 and 255. So with that in mind, the way I got this amount of devices that could be on this Class A subnet network is 255 times 255 times 255, which would be a total of 16 million devices that could be on a Class A network. So just wanted to give you kind of that terminology. Plus, to be honest with you, I'm tired of saying 255, 255, 255. I'm just going to call it a Class C subnet from now on, or at least try to. So that pretty much goes over our review that we did for video 2, things we talked about in video 2. So now let's go ahead and talk about DHCP. So again, DHCP stands for Dynamic Host Control Protocol. And if you remember the protocol, it's just a protocol is just a configuration, or really not a configuration. It's just a set of rules that everybody's agreed upon that'll run on a network that does a specific job, and that's pretty much all it is. So these are the terms we're going to learn about. The DHCP server, it gives all the TCP/IP info needed to a device so it can communicate on a network. The info it gives is the IP address, subnet, gateway, and DNS. Those are the things that you have to communicate on the network. If you remember the IP address and subnet, you have to have that to communicate on your local network, and you need the gateway and DNS to get off of your local network. The gateway by itself specifically, but really when you get off the local network, you're going to want to find some name or web page probably, so there's where DNS comes in to convert your names to IP addresses so you can move around to the computers you want to go to. The NIC stands for Network Interface Card, which most of our devices, a lot of our devices that go out that have them, and of course they have to have them to connect to a network. The MAC address, that's a unique number that identifies a NIC, sometimes called the physical address or the hardware address. Some people call it the hardware address. But anyway, it's really attached to the piece of hardware or the network interface card to identify it. Unlike the IP address, which can change on the network interface card, the MAC address stays the same. So then the last thing here, we have a lease, and that's the amount of time until your IP address will be available for someone else to use, basically. So let's go ahead and open up a command prompt again. So we're going to the Windows R, open up the run command, type in CMD, hit enter, and we're going to go ipconfig all /all. And we're going to look at a few terms here. I'm going to scroll back up to our local area network card, which is right here. And if you notice, right up here it tells me I have a gigabyte Ethernet NIC. So that's how fast it can go. Gigabit bandwidth. The physical address, here's where it calls a physical address. Like I said, some documentation will call it a MAC address or hardware address, but this is called hexadecimal here, this number, and so it's 6C 62 6D 92 1884. So that will, as a hard address attached to that network interface card, it's unique in all the world. No network interface cards have the same one on purpose. I'm sure there's been some accidental runs sometimes, and they might have messed up and got the same MAC address on two different network interface cards, but they're supposed to all be unique. You notice on this network interface card we have DHCP enabled. We have auto configuration enabled for DHCP. We have the IP version 4 address. So when this network interface card booted up and it went out to the DHCP server and it asked for an address, the DHCP server gave it 192.168.0.100. It gave it the Class C subnet address. Again, if you remember, the 255s mask out the network address, and then where there's a 0, it leaves that open for the devices to use. So any number between 0 and 255 would function on this network with no gateway. Shows the lease was obtained on Monday, October 31st, and the lease will expire on Thursday, November the 10th. We'll talk about that a little bit more. First, I want to go to the default gateway and the DHCP server and the DNS server. So you notice our DHCP server is 192.168.0.1. So that protocol, this is the device or computer, which is my router box, that is running the DHCP server to give out information for devices that try to boot up on my network so they can all communicate. And then the DNS server, it's also handing out the name. So if you type in www.yahoo.com, that information will go directly to my router, and my router will resolve that name and give an IP address back so the computer can find where it needs to go. And of course the default gateway is my router that gets me out to the internet. So let's take a look at my router, the web page of my router, and let's look at the DHCP server in particular. So let's bring over here Internet Explorer, and most of you can probably guess the number I'm going to type in here. It's just going to be the number of my router, which is 192.168.0.1. I'm going to hit enter. So this is the web page of my router. I have a D-Link DIR 615. It's a wireless router, so it has wireless as well as wired. And I'm going to type in my password and log in. And so here's my web interface. So I'm going to go to my network settings, and here's my router settings. So the IP address of my router we're already familiar with is the 192.168.0.1. I got the Class C subnet there, so I could have 255 devices on this network. There's the name of my router, and then right here is my DHCP server settings. So if you notice, I have DHCP enabled, so that means that protocol is running on this device, and it will hand out addresses, and the IP range it will hand out is anywhere from 100 to 199. Now you'll notice that per our discussions before, that when we are on a Class C subnet like we are up here, the 255s are going to mask out 192, 168, and 0 as being our network, and so that's going to leave the 255 devices left here, so anywhere between 0 and 255. Well, we're only going to hand out addresses from 100 to 199, so that would leave anywhere from 0 to 100, and 200 to 255 would be outside of our range. So if we wanted to give a static address to something on this network, we could feel comfortable that our DHCP server wouldn't hand out the same address, which would cause a problem, and it would then be able to function still on the network but outside of this range. So you always want to have a static address. If you hard code an address in and don't let it use the DHCP server, then you always want it outside what your IP address range is for the DHCP server. This is telling me how long the lease is, how long can a device have the address before it has to renew it, and that's 10,080 minutes, which is just a little bit over a week. And it always broadcasts and advertises that this device is a DHCP server, so when a network interface card boots up on the network, it'll know that it can get an address from here. And then now, the thing that we can do, which we do at Purdue all the time, is we could actually make a static address inside this range if we want. And we would call that a reservation. And if you look down here, here is a list of all the devices, all the computers that have got IP addresses from this DHCP server, and what their hardware address is, or MAC address, or physical address, and what IP address the DHCP server gave them. And this kind of gives a little, this is the host name, so Shuttle's my computer. Of course, the notebook computer is a notebook computer. Acer is my wife's computer. Brenton's my son's computer. Python's my other son. He just wanted to name it that, so I did. And then Nancy down here is my wife's notebook computer. But some of these other devices, just a specialized USB device I have that handed out an address to it. But anyway, when you look at all those, it shows you when the lease expires on them. And then over here, if you notice this link, I could revoke this and make it get a different address if I wanted to, or I have this ability to reserve it. Now, this is going to be a very similar procedure that would be done at Purdue or another a big account that would want to get a DHCP address but have it static by reserving it. And so the way they would do that, they would do a similar procedure. They would click reserve, and when they did that, notice it put in the shuttle up here and the IP address that it has, and then it put its MAC address in here. And then when you save that, then whenever so this is really just as good as a static address. As soon as you save that, then it's going to remember that MAC address. So whenever that MAC address boots up on the network, it's going to automatically give it that address. And so this is really just as good as static. The benefit of doing this is all the other information that the actual machine needs or device needs to function on the network is actually given to it also, like DNS servers, gateway, all that stuff is all given to it also, and you don't have to type it in. And if the DNS server changes, the DHCP server can be changed, and all the devices that are using it can be changed. So that's some of the benefits of actually having that ability to reserve address inside this range. So that gives you kind of a good idea of what DNS is, and I'm sorry, excuse me, DHCP is, and how you would reserve and why you would reserve an actual address. So hopefully that was helpful to you, and I will see you next time with another video. Have a good day.